Here. I'll begin with a word of prayer. Dearly Father, we thank you for this day. I thank you for these students. Just ask you to guide our work and help us to glorify you in what we do, Lord. In your name I pray, Lord Jesus. Amen. Okay, so if I worked this last class, my apologies. You guys say I didn't, so I'm going to trust you on it. Here it is. So, example 1. So we're looking to fit this parabola y equals ax squared plus bx plus c. Goes through three points, right? Given below. Find the values for A, B, and C, all right? And so the points which are given are 2, minus 8, minus 4, minus 68, and minus 3, minus 38, all right? And so what we want to do is we want to plug those points into the formula for the parabola and then see what that's going to do for us, all right? So you guys help me out. What's the first equation I get? See, the y is minus 8, right? Equals to a times 2 squared, right? Plus b times 2 plus c. And then this next point gives me the equation minus 68 equals a times minus 4 squared plus b times minus 4 plus c. And the third point gives me the equation minus 38 equals to a times minus 3 quantity squared plus b times minus 3 plus c. All right. Now, we should clean these equations up, right? Let's clean them up. What's the equation actually look like? It's so what we got ourselves is here is a 4a, right? 4a plus 2b plus c equals to minus 8. I've got myself a 16a minus 4b plus c equals to minus 68. And a 9a minus 3b plus c equals to minus 38. All right, and let's label these equations 1, 2, and 3. Okay? So 1, 2, 3. Ooh, horrible. All right. So remember last time I shared with you guys a strategy for solving 3 equations and 3 unknowns? What did I tell you? Step 1, eliminate z from equations 1 and 2. Then eliminate z from equations 2 and 3, right? So here we have ABC rather than XYZ, right? But the same strategy applies. What we want to do is eliminate C from equations 1 and 2, and then eliminate C from equations 2 and 3. That will bring us down to 2 equations and 2 unknowns with just x and y. That's the strategy we should adopt here. So it's really pretty obvious what to do, right? Equation 1 minus equation 2. 1 minus 2, what's that give us? Minus 12a, right? Plus 6b. The c's cancel, and we get equals to 60, right? So that's equation 1 minus equation 2. If we do equation 2 minus equation 3, what's that give me? Equation 2 minus equation 3, 16 minus 9 is 7a. Minus 4 minus a 3, minus a minus 3 is like plus 3, so we get minus b. And then the c's cancel again, and we get minus 68 plus 38, which is minus 30. Do you guys follow that? I mean, I like to write those kind of steps right below it, but my handwriting's horrible down here, so I put it up there. Sorry about that. Yeah. Now what? Now I've got two equations and two unknowns. I can solve that, right? How would you guys suggest I solve this? I think there's a clear choice for me how to go forward on this pair of equations. Let me call these equations 4 and 5, yeah? What do you think I should do with equations 4 and 5? Oof, garbage. This thing's garbage. I had some battery problems today. Oh, my mic's still working good. Did you guys, what would you suggest? Anybody? We're not here to think, you're here to wait for the break to start, is that right? Okay, I understand. How about this? Take equation 5, solve for b. That's super easy, right? Because b's, you don't even have to, you just isolate b, right? B is equal to what? 7a plus 30, right? I'm getting that from 5, right? And then once you know that, we can substitute that into what? Substitute it into 4, and that gives me what? Minus 12a plus 6 times 7a plus 30, right? Equals to what? 60, right? But now, one equation and one unknown. We're almost home free, right? So we've got minus 12a plus 42a plus 180 equals to 60, which gives me 30a is 60 minus 180. 60 minus 180 is minus 120, right? So what's that tell us a is equal to? Minus 120 over 30, also known as a equals to minus 4. And once you have the values of one of the variables, then you just kind of have to back substitute, right? So we've got the a equals to 4. Now how do I get b? Right here, right? 7a minus 4 plus 30, so b is equal to minus 28 plus 30, that's 2, right? And how do I find c? Pick your poison, whichever one you want from the initial set of equations, right? Let's use the first one just for the sake of specificity. C is equal to, solving number 1, from 1 I get c is equal to minus 8 minus 4a minus 2b, right? But that is minus 8 minus 4 times minus 4 minus 2 times 2, right? And that's actually, you get a 16 from the middle term, but you got a minus 8 and a minus 4 on the outer skirts of that calculation. So that's really 16 minus 12. 16 minus 12 is 4. So we got a equals minus 4, b equals 2, c equals 4, right? That's not the answer. What's the answer? We need to go back to what the problem's about, right? The answer is we're supposed to find the formula for this. So what's the formula that we found? Put it all together, right? Y equals 2, a was what? Minus 4, so minus 4x squared. What was b? b was 2 plus 2x. What was c? c was 4 plus 4. That's good. So that's how you can work these. Basically, you just plug the points in and then solve the system of equations, right? So they're not too bad. That's number 26. Number 25 is like this problem, but easier because it's just with lines. Let's look at number 27. Okay. Example 2. Here we're facing x plus y equals to 13. X squared plus y squared equals to 85. And you're supposed to fill in the blank. The nonlinear system above has two solutions, one of which is parentheses 6 comma fill in the blank. So this question is very dumb in some sense, because it's like I don't know. I think the other problems are more interesting in some regard, but this is a good place to start. This one's easier than the later problems. This is number 27. Why is this easy? I say it's easy. Well, they kind of told you they told you half the story at the start, right? They told you that you're looking for a solution with x equal to what? 6. So what can you do? Right, you can put x equal to 6 in both equations, right? So what's that look like? See, we're trying to solve both equations at once, right? Simultaneous solution. And all right, so here we go. We got 6 plus y equals to 13. And we've also got 6 squared, which is 36, right? 36 plus y squared equals to 85. So what's the blue equation tell you? The blue equation tells me y is equal to 7, right? What's the black equation tell me? The black equation, it tells me that y squared is 49, which then tells me that y is equal to plus or minus 7. Taking the square root plus or minus property, right? Now, it is true that when x equals to 6, you have either plus or minus 7 as the solution for the second equation there, right? But does that matter? I mean, that minus 7 solution is extraneous, right? Because it doesn't solve the first equation. You have to solve both at the same time. So the answer, what we should fill in the blank with, is what? 7, right? So the answer here would be 7. I think it's helpful. Like, I would encourage you, as you're working these problems, you do need to figure out how to work them by hand, right? But it's not unwise to use Wolfram Alpha to look at what you're doing, all right? Or you could use Desmos, I suppose, but I think Wolfram Alpha works out pretty good here. Let me show you what I'm talking about. I think I didn't pan over there, did I? Oh, so sorry, people not here. I guess I could have warned you this would happen. We didn't miss much. What did we do? We just plugged 6 into here and here, because we're given x equals to 6 from that, which gave us this equation and this equation, which we solved either for just 7 or for plus or minus 7. But we have to solve both equations, so we ignore the minus. Doesn't count, right? And there's that. Now, I want to show you. The problem indicates that there are two solutions, right? But it only asks you for the one, right? It is instructive to see what the other solution looks like. And once the thing warms up here, we'll project it. Come on. In the meanwhile, I will open up the dreaded top hat. $37.17. All right, 37.17. There it is. All right, so let's look at Wolfram Alpha for a second here. So what I did, my entry, what I entered here, let me show you how I did this. So in Wolfram Alpha, if you want to solve a system of equations, it's very simple. All you do is you write the equation and then put a comma between the other one you're interested in. All right, so like, come on. So here, see see what I did? This is the problem we were just working, right? X plus y equals to 13. X squared plus y squared equals to 85, right? And I hit enter, and it tells me things that it thinks someone might be interested in if they looked at those two equations, right? So they might be interested in, for example, the graph. The graph of x plus y is this line, right? The graph of x squared plus y squared is a circle, right? Notice that the y-axis is right here. See 0? So like the y-intercept is like about 13, right? This, you can solve for y. This is y is 13 minus x, right? It's a slope. It's a line with slope -1. It's got a y-intercept of 13. What would happen here? And you can scroll down, right? I can scroll down a bit. It'll actually show us the answers as well. So the solutions are, like we found, x equals 6, y equals 7. If instead of putting x equal to 6, you put x equal to 7, you get y equals to 6. That's the other solution that the problem doesn't ask for, but there it is, right? So listen, when we started solving two equations and two unknowns, what did I do? I talked about the geometric meaning for it, right? We have two lines. They're either skew, so they intersect at a unique point, right? They're parallel, so they don't intersect anywhere, right? Or they could be the same line. And that informed us we either have a unique solution, no solution, or infinitely many. Now we're solving nonlinear equations, right? So the possibilities are more interesting. We've studied, right, what circles look like, x squared plus y squared. That's a circle. So if you think about how a circle passes through a line, you can kind of, it's not surprising that you got two solutions, right? What do you think is going to happen if I increase the y-intercept from 13 to like 15? What's going to happen? What do you think will happen if I increase the y-intercept to 15 on this problem? Let's try it out. See that? Now, there is no intersection between the line and the circle. So I expect when we try to solve the system that's just a little bit different, if we try to solve x plus y equals to 15, right? And x squared plus y squared equals to 85, it's going to have no solution, right? Okay, so you're like, so we have to graph it to know that? Well, we don't have to graph it to know that, all right? We can approach it algebraically. Let me show you how to do that, yeah? If I can find a marker that I like. Let's see here. Now, did we have to go through some algebraic procedure for number 27? Not really, right? Because it was so kind of artificially contrived. They told you 6, right? But what happens if we just face this problem without somebody coming in and telling you x equals to 6? How do you solve it, you know? What if instead of putting 13, I put 15 here? I expect that when I put this 15 here, it's going to make this problem have no real solutions. Listen, your homework has some stuff about complex exponents. I have no earthly idea what it's talking about. Like, I wouldn't cover complex exponents in this course unless I was really, really misbehaving, but I'm trying not to misbehave that much this semester. So, oh man. Come on, stupid battery. Power cord. Just a second here, I gotta plug my camera back in, otherwise we're gonna run out of batteries. There we go. Okay. So how would you guys think we should solve this? What do you think? How would you go about solving this problem? This is not 27. This is a problem related to 27, but not the same, okay? How do you solve this system? What do you do? See, we can use the ideas that we talked about for two equations and two unknowns, and we can just twist them a little bit, and we can solve this. I think substitution's the way to solve this one. Well, substitute? What do you mean substitute? How about this? If we take the first equation and we solve it for y, we get y equals what? 15 minus x, right? Yeah? Then what I can do is I can substitute that, right? I can substitute this into that. And when I do that, I'm having an equation just involving x. And you're like, that seems ugly. Well, a little bit, but not too bad. Nothing we can't handle. See, because that's the equation we face. What is that? Well, that's a quadratic equation, right? We can solve those. We just need to work it out, right? 15 squared is 225. So this foils out to x squared plus 225 minus 30x plus x squared equals to 85, right? And then if you clean that up, what we got is a 2x squared minus 30x. What's 225 minus 85? It's a reason for me to go get my calculator, is what it is. I mean, I don't want to get it wrong. I'm just tired enough to make a mistake at the moment. Minus 85. 140. So plus 140 equal to 0. Now how do we decide whether or not that has a solution? What do we do? Ooh, I think we divide by 2, right? Because there's a 2 everywhere, so make this easier. This is x squared minus 15x plus 70 equal to 0, right? And you can complete the square here. You could use the quadratic formula. You guys, you choose. What do you want me to do? Complete the square or quadratic formula? Student's choice.
Complete the square.
Complete the square it is. Making me work for it, huh? All right, so x minus 15 over 2, quantity squared. But then to be fair, I have to subtract the square of 15 over 2, which is 225 over 4. And then I still have to add 70, right? So that gives me x minus 15 over 2, quantity squared, equals to minus 70 plus 225 over 4. Now let me just use my calculator there for a second. I mean, you could work it out. It's minus 280 plus 225, which is, all right, let me stop that. You guys probably should use your calculator for that. Minus 70 plus 225 divided by 4. That gives us minus 55 over 4, which then gives me x is equal to 15 over 2 plus or minus I times the square root of 55 over 2. What does that mean? What does that mean for us? What that means is there's no real solution, right? So no solution. Which makes sense, right? Why? Because there was no point of intersection, right? There's no place where both equations are true. Shall we go on? I think we shall. Let's see here. So next up, let's work number 28. I'll work it over here. Actually, everybody's over here. I'll work it over here. Do you guys have this one? Okay. Can I erase? Is that a yes or no? You good? Okay. So this one this one we just worked, example 2, yelled substitution at me, right? The next one, you guys tell me what you think once you see it. Here we're facing 4x squared plus 5y squared equals to 41, and 5x squared minus 2y squared equals to 43. Do you guys have any ideas about how we might solve that one? How about this? We can think of x squared and y squared kind of as variables and just think about trying to eliminate them, right? Like if I can get rid of y squared and just have x squared, then I have a quadratic, I can solve it, you know? So how do I make the y squared terms like match up so that they can go away? Right? That's my That's my question. How can I make these guys cancel out? What do I need to do? How about this? I do 2 times equation 1, which gives me 8x squared plus 10y squared equals to 82, right? And then what? Sorry, never. Trying to see my stupid monitor. What's that? 5 times 2? Yeah, 5 times equation 2. I like that, yeah. And what's that give us? That gives us, what we got here? 5 times 5 is 25. X squared. All right, enough of this marker. Finally. All right, and then 5, so minus 10. Y squared equals to 5 times 43, which is 215. All right. Then what you want to do is add these equations, right? We add them. That makes the y squareds go away. 8 plus 25 is 33. X squared equals to, the y squareds cancel. And what's 82 plus 215? 297. And what's 297 over 33? Nine. It's 9. Because 330 less 33 is 297. And also somebody told me this in the earlier section today, so I already know. But anyway, so I'm cheating. So we got x squared equals to 9. So then what's x equal to? So x is equal to plus or minus the square root of 9, also known as plus or minus 3, right? And if x is plus or minus 3, what is y? See, you can go back to either one, right? Either equation 1 or equation 2. Let's use equation 1, right? From 1, we've got 4 times plus or minus 3 squared, right? Well, don't even think about it like that. Don't think about it like that. What is the square of x? It's already sitting there. We don't need to recalculate it. Use it. It's right there. What is x squared? Don't be dumb about it like me. 4 times what? X squared is 9. So 4 times 9. And then plus 5y squared, which we don't know yet, equals 41. 4 times 9 is 36. Right? So we've got 5y squared equals to 41 minus 36. 41 minus 36 is 5. So lo and behold, we've got y squared equals to 1. Which then, taking the square root of the equation and allowing for plus minus, we get y equals to plus or minus 1. So you got x is plus or minus 3, you've got y is plus or minus 1. What's the solution then? The solution set for this one would be we do x is 3, y is 1. But we can also have x is 3, y is minus 1. But we can also have x is minus 3, y is 1. But we can also have x is minus 3 and y is minus 1. There are 4 solutions to this problem. And if we look at it, if we go take a look at it in the Wolfram Alpha, just to double check what we're doing, right? It will make sense. Let's try it out. So you guys tell me back the equation. What was it? 4x squared. Squared equals to what was it? 41. And the other one was what? Minus 2y squared equals what? 43. What's going to happen here? Let's see here. Ooh, look at that. So, see, well, you guys, we haven't talked about these, have we? Because I just talked to you guys about circles, didn't I? So, if I had done my job better this semester, if I'd been meaner to you, let's say, we could have talked about this intelligently and geometrically. See, because equations like this, when you don't have the same number on the x squared and the y squared terms, those give you ellipses. See, that's an ellipse. It's a squished circle, right? On the other hand, when you have something like x squared minus 2y squared equals to 43, where you got a plus minus pattern, that gives you what's called a hyperbola. Okay? These are both examples of what are called conic sections, all right? The only thing I hold you responsible for graphically in here is circles, right? We've talked about circles carefully. So I'm not going to test you on graphing hyperbolas or ellipses, right? But I think it's comforting to know a little bit about them so that you can understand what we're finding algebraically in this problem. Why there are 4 solutions, it's because you get those 4 points of intersection, right? So it's not surprising. So my apologies that I didn't make you do more work this semester. I guess I should have. But can you forgive me? Dr. Putney's got his class doing the hyperbolas, you know. So I'm sure I was meaner to you in some way or another than Dr. Putney. Let's see here. What else we got? Number 29. I'll see what number 29 is. I'll do that one over here for a change of pace. So number 29 is, this time we're up against 3x squared plus 3y squared equals to 39, and 9x squared plus 9y squared equals to 78. Huh. That's funny. Now this one I think you could solve geometrically. And that's, if you can solve a problem geometrically, then that might be the fastest way to solve it, all right? So I say you could solve this geometrically. Can you guys tell me geometrically what those equations are? If you multiply the first equation by 2, it gives you the second one? Is that right? Oh, almost. Almost. But not on both sides. Because I need to multiply this by 3. To match the left-hand side up, I need to multiply by 3. You're right that that's 2 times that. But listen, let me make this easier for us. So this is example, what example is this for me? Sorry guys. 4, right? Example 4. So this one, yeah, goodness, I mean, we could take an algebraic approach, right? Certainly we could. This gives me, and maybe we should do that, I don't know. So this is x squared plus y squared, divide by 3. 39 over 3 is 13, right? The second one, divide by 9. What'd you get? 78 over 9 is what? Nothing pretty, right? It is what it is, 78 over 9. Like 72 over 9 is 8. So it's whatever, it is what it is. Those are circles, right? Centered at the origin, right? What's the radius? The radius of this one is the square root of 13, right? The radius of this one is the square root of 78 over 9. And just for the sake of conversation, let me figure out what that is, okay? 78 divided by 9, take the square root of that thing, we get 2.94, okay? So this is approximately 2.94, okay? Square root of 13 is approximately, what's that? Just for the sake of discussion here. 3.61. So what's going on here graphically? You've got 2 circles, right? Concentrically situated about the origin. The one has radius 2.94, right? And the other one has radius what? About 3.61. Do those intersect? right? So this would be, which one's the bigger one? This one. This is 1. And color coding here, the graph of equation 2 is in blue, okay? So the answer is solution set. It's the empty set. It's the set which contains nothing. Nothing. Algebraically, how would we have found that? How about this? The algebra way to do this, if you don't want to graph it, if you want to understand it algebraically, it's really very simple. All you do, all right, follow me on this, you take these two equations, right? And solve both of them for x squared plus y squared. See, what does that say? It says 13 is x squared plus y squared, right? But it's also equal to what? 78 over 9. But is 13 equal to 78 over 9? So this is absolute nonsense, right? This is magaga. Right? Just crazy talk. So, sorry, I just, magaga. Do you guys know about the magaga? So Donald Trump has come out and announced his candidacy. He said, it's no longer Make America Great Again. Now it's Make America Great Again and Glorious. No, Make America Great and Glorious Again. Magaga. Something like why? No. Stop that. Anyway, I'm sorry. I know you guys are all Trump fans. My bad. Let's see here. So, you know, and of course you could stick it in the Wolfram Alpha and look at it, but I don't think we need to for this one. Let's go on to this one was number 29, okay? So number 30 is what? What is number 30? What is number 30 to you? How does it relate to your semester? Can you tell me? What the significance of number 30 in week 14 homework and week 13 homework is? Oh man, I really hope I had that. I hope I think I was over there before. I want to believe that I recorded that. Let's believe that I recorded it. You guys will be nice and copy your notes for the people who weren't here if something happened, right? You have a picture of it? Okay, so if worse comes to worse, I'll get your picture. All right, so this is an important homework problem. Maybe the most important homework problem of the entire semester. Because this is the last homework problem of the entire semester. This is it. This is the end of the road, the last one. So here we go. X squared plus y squared equals to 1. And, absolute value of x minus y equals to 1. How are we going to solve this problem? I think any of these problems, it's wise to try to graph it if you can, because that way you can anticipate what you should be looking for, all right? This one we can graph, because x squared plus y squared equals to 1 is what? That's a circle, right? It's the unit circle, isn't it? Radius 1? Like if there's any circle that you know about, it ought to be that one, right? That's the unit circle. How about the second equation? What's that? So if we solve this, we get y equals to what? Y equals to absolute value of x minus 1, right? But you guys know how to graph absolute value of x. Remember that? That's the one that's a v, right? And minus 1 just means we translate that thing 1 unit down, right? So the graph here is nothing more. This point right here, by the way, is 0 minus 1, right? And so this, we take the v, we shift it down 1, so it looks like this. I'm not saying it goes through there. I'm not sure exactly where it goes, you know, but something like this. It may well go through the x-axis there. So I'm expecting that when we work out the algebra for this problem, we should find 3 answers. And in fact, if I made the graph real careful here, I probably could already tell you those 3 answers. Maybe you can without even doing algebra, can you? What are the 3 answers here? -1 plus 1. But remember, the answer has to be a pair. It has to be, like I already wrote the 1. 0 minus 1, I believe, is a solution. Because if you plug this into this, you get 0 squared plus minus 1 squared equals to 1. So it checks the first equation, right? If you plug in 0 minus 1 into here, you get 0 minus a minus 1, which is 1. So that works. This solves both of the equations.
So that's one of the answers?
That's one of the answers, yeah.
So it would be -1, 0, and then...
Yeah, I think these other ones are probably going to be 1, 0, right? And this one, if I had to guess, it would be -1, 0. I think those will work. But, okay, this problem was nice. It's not always nice like this, right? So let us try to face the music here and work it out algebraically so we're not, too reliant. We got lucky in the graph being sufficiently clear to see the answers, right? That doesn't have to happen. I mean, it could be that it's easy to think about a problem that looks pretty much just like this, but something like this. So that the intersection points up here are not easy to see what they are, right? So let's work out the algebra, see how we would do it. How would you do the algebra here? I think what we want to do is substitution again. So if you look at equations 1 and 2, right? Which one should you solve for a variable to eliminate it? I think we should use 2 and solve for y. Actually, okay, I mean, it's right there, right? Solve for y. And then what? Substitute that into 1. See, because if we do that, then what happens? We get, x squared plus the absolute value of x minus 1 quantity squared equals to 1. Now, have you ever thought about squaring absolute value? Maybe not. Here's a formula for absolute value. Absolute value of x is equal to the square root of x squared, right? So if I square the absolute value function, that's just squaring the square root of x squared. So of course that's equal to x squared. So anyway, let's work this out here. So we've got x squared plus the absolute value of x squared minus 2 absolute value of x plus 1, foiling that out, equals to 1. But what is that? Well, that's x squared plus x squared minus 2 absolute value of x equals to 0. Which is what? So I got 2x squared equals to 2 times the absolute value of x. Excuse me. So this brings us to x squared equals to the absolute value of x, yeah? How can you solve that? I mean, there are various ways, but one way to do it, which I like, is this. That's the square root of x squared. So if I take this equation and I square both sides, what's that take me to? I get x squared squared equals to the square root of x squared squared, which gives me what? This gives me x to the 4th equals x squared, which then I can rearrange and look at that as x to the 4th minus x squared equals to 0. Factor x squared out. I've got x squared minus 1 equals to 0. Factor that. Get that. And then, so what's the answers? The answers are x equals 0, minus 1, and 1. And then, of course, you can go back in and run it through the y equals absolute value of x minus 1 formula, right? And then since y equals absolute value of x minus 1, this gives us the points 0, minus 1, minus 1, 0, and 1, 0. Those are your solutions. That put brackets around it. That's your solution set. Which of course is what we argued geometrically to start with, as you saw, right? Listen, maybe you don't like the way I solved the end of this problem. Do you guys have any other ideas about how we could have solved this? How could you solve x squared? Let's talk about this. How do you solve x squared equals the absolute value of x? What's another way you could do that? Suppose you don't like my factor-heavy argument there. How else would you do that? Any ideas? So the other way you could have thought through it is this, okay? If we have x squared equals the absolute value of x, right? Then that means it's plus or minus x, right? So if we divide by x, that gives us what? X equals to plus or minus 1. What happens when you divide by x, though? What are you losing when you do that? When can you not divide by x? When x equals to what? 0, right? So before you divide by x, you could say, we see x equals to 0 is one solution, right? Divide by that then, and then you get x is equal to x squared over x is x. X over x is 1, so you get plus or minus 1. And of course, those are exactly the 3 solutions I found by the factoring idea, right? Factoring is safe. This kind of logic you have to be careful with, because if you're not careful, you'll miss the 0. And you'll just trick yourself into thinking plus and minus 1 are the only solutions, when in fact there are 3, right? Which is why the graph is nice, because it keeps us honest. But anyway, that's it. Hey guys, have a good break. I will see you on the other side, I hope.